Now we want to talk about this concept of inertia, and this is fundamental to Newton's laws. So inertia is simply a measure of the resistance an object has to moving. Okay, inertia is resistance to motion. All right, so inertia being resistance to motion. Now imagine two objects, say one kilogram and another is say 10 kilograms, right? And you give them both equal pushes, all right? So I push 1 kilogram and I push 10 kilograms and I push them equally. Which one is going to move faster, all right? Well, common sense would say, well, the 1 kilogram object, right? It's smaller, so if I give it a push, and if I give a larger object an equal push, then it's going to be easier to move the smaller object. So what we're really saying with this is that mass is a measure of the inertia of an object. Okay, so mass is a measure of inertia. Okay, so mass is a measure of inertia. So when we say F equals ma, let's break this equation down a little bit, right? Let's look at F equals ma. And really kind of think this through, all right? What this is saying is that if I apply a force to an object, then that force is going to be equal to the acceleration the object experiences times the mass of that object, okay? So the force is going to be an external thing to the object. So in the case of me pushing my 1 kilogram object, then the force that I supply is what's on this side of the equation. The mass of the 1 kilogram object goes here, so 1 kilogram, and then whatever its acceleration is determined to be. Let's say I have a motion detector and it does all sorts of fancy things, and it calculates the acceleration of the object. What I will find is that the force that I push is going to equal the mass of the object times the acceleration. Now, perhaps a slightly more intuitive way, at least to understand what's happening, is to rewrite this equation like this. All right, all I've done is rearrange the equation slightly. And what this equation is saying is that for any given acceleration an object experiences, that acceleration is going to be proportional to the force, but inversely proportional to the mass. So, for any acceleration, the mass is going to be inversely proportional to that acceleration, meaning the larger the mass, the smaller the acceleration for any given force. And that's exactly what we said with the two objects, 1 kilogram, 10 kilograms, and I push them both with the same force. The heavier mass, whatever that force that I calculate or that I push them with, divided by their mass is going to equal their acceleration. So let's say that I give them both a push of 20 newtons, say, right? So 20 divided by 1 is going to be the acceleration of the 1 kilogram object. 20 divided by 10 is going to be the acceleration of the 10 kilogram object. So the acceleration an object experiences is inversely proportional to the mass. Now remember, the mass is a measure of inertia. It is its resistance to motion. So it would make sense that a heavier object, an object with more inertia, is going to experience a smaller acceleration for any given force. All right, I just wanted to make that very, very clear. Now let's do a quick example. And before we do that, let's introduce the units on force. Okay, so force is going to have units of kilograms times meters per second squared. Okay, so those are the units on force. All right, and I use these brackets to note units. All right, that's all I'm doing. So my mass is going to be measured in kilograms, my acceleration in meters per second squared. So these are the units on force. All right, and so we call kilograms times meters per second squared, we call those newtons, of course, after Sir Isaac Newton. So force is measured in newtons, And the definition of 1 Newton, all right, the definition of 1 Newton, I'll put it up here. 1 Newton is equal to the acceleration of 1 meter per second squared applied to 1 kilogram. Okay, so if I have an object of 1 kilogram and it's accelerating at a rate of 1 meter per second squared, then that is the definition of 1 Newton. So if I have a 1 kilogram mass and I drop it and it's accelerating at 10 meters per second squared, 9.8 is close to 10, then it has a weight or a force of 10 newtons, okay? All right, now let's do a quick example here. And let's say that we have a car